Hello friends, welcome back to our channel Adami Education. Since we have not been doing live for a few days because there are board examinations going on, also class 9 and class 8 examinations are going on. So I decided to upload a video based on the first chapter of physics. So whenever the exams get over, the students who want it can view it easily. So the first chapter of physics, ICSE, it is force. So already you have studied a lot about force in class 9. In this chapter, we are going to basically focus on rotational motion and also about center of gravity. And we also have quite a good number of numericals in this chapter. So I would request you all to be very patient when you're doing this chapter, because one question can yield a good amount of marks, especially if it is a numerical. So let's begin. First of all, let's do a quick recapitulation on the types of motion which can be observed whenever a force is acting on a body. Whenever a rigid body, a body which cannot change its shape or size just like that, only when a very huge amount of force is applied, only then it will change its size or shape. So in such a body, whenever a force is applied, two kinds of motion is possible. Either the body will continue to move in a straight line, which is also known as linear or translational motion. For example, if we just roll a ball on the floor, it can move in a straight line, so that will be translational motion. Now if we are trying to move the object in a circular motion such that it is pivoted at a particular point, and then we are applying a force which moves the object in a circular motion. For example, if we consider that we have taken a circular disc and it is pivoted at the center at some point like a nail or something, and then we are applying a force such that it starts moving in a circular motion, such type of motion is known as rotational motion. So these are the two types of motion which can be observed whenever a force is applied to a rigid body. Now coming to a term which is known as moment of force or torque. So moment of force or torque occurs whenever we are causing a turning effect on any body. That means a rotational motion is occurring. So what are the factors which affect this turning effect? First of all, obviously the magnitude of the force which we are applying. Without the force, no turning effect can occur. So the magnitude of force is one of the factors. Also, the distance of the line of action of the force from the axis of rotation. So at the point where the object is pivoted, from that point, if we consider the distance of the force, the perpendicular distance, we will see it in the next few minutes whenever I'll show you using a diagram, then you will understand it much better. So that particular distance of the action of the point where you're applying the force and the point where the pivot is located, that perpendicular distance is also a very important factor which affects the turning motion of a body. Alright, so this turning effect is due to the term or due to the quantity which is known as the moment of force or torque, and whenever turning effect occurs, we can always say that torque is present there. So what is torque? What is the definition of this moment of force? The moment of force or torque is equal to the product of the magnitude of the force which we are applying, and the perpendicular distance. Like I told you, what perpendicular distance? It is the perpendicular distance of the line of action of the force, the point where the force is getting applied, from the point where the object is pivoted. So that perpendicular distance into the magnitude of the force, into the force which you are applying, that will give you the torque. So now let's come to the diagrammatical explanation of the same. So for example, I have considered an object like this and it is pivoted at this particular point. Let me term it as O. Okay, so this object is moving in a circular motion and it is pivoted at point O. So we have applied force in this direction. Just imagine, okay, this is the force. So what will happen? I'm just going to extend this line further, the line of the force, and this is my point of pivot, the point O. From that point, if I draw a perpendicular line to the line of action of the force, so the line of action of the force, let me term it as AB. So to AB, if I draw a perpendicular line from the point O, from the point of pivot, and I mark the point as P, so OP is the perpendicular distance which I was talking about. So what will be the torque? The torque will be equal to, like we saw, it was the product of the force, that means force into what was the perpendicular distance, OP. So force into the perpendicular distance will give you torque. So torque is also written by using the symbol tau. So tau is equal to force into perpendicular distance. So let me term it as small d. So force into d is equal to the moment of force or torque. I hope now using the diagram it is much more clearer. Now coming to the units of torque, we know that torque is equal to force into distance, the perpendicular distance. So force has a unit Newton and distance has an SI unit Newton meter. So Newton meter is the SI unit, and if you want to consider the CGS unit, it will be dyne centimeter, because dyne is the CGS unit of force and centimeter is the CGS unit of distance. So dyne centimeter will be the CGS unit of torque. Now torque is a vector quantity. We just saw that depending upon the point of the force, we can determine the direction of the moment of force, because if we consider force in this direction, that means force is applying like this. This is the direction of the force at every point. That means the object will move in an anti-clockwise direction, isn't it? Otherwise, now if the force is being applied in this direction like this, the object will move in a clockwise direction. So depending upon the point of application of the force, we can say that the object will move in either a clockwise or in an anti-clockwise direction, and as a result we will also have a different direction for the moment of force. So it is a vector quantity because it has to be determined by the particular direction. Hope it is clear. Now, what are anti-clockwise and clockwise moments? Let us understand about that in detail. So, if the moment of force is anti-clockwise, that means the object is moving in an anti-clockwise direction, like I just showed you. And whenever anti-clockwise moment is occurring, we will say that it is positive in nature. Very important. We might think that anti-clockwise means negative, but no. Over here it is different. So whenever anti-clockwise moment is there or anti-clockwise motion is there, we have to consider that the moment is positive in nature and vice versa. That means whenever the moment is in the clockwise direction, the moment of force is taken to be negative. So this is a very important understanding because it might be asked for 1 to 2 marks. Now over here we have two objects. The same object, it has been pivoted at the same point O, but the point of application of the force will be different in either case. In the first case, the force is being applied in this direction. So what will happen? The object will move like this, anti-clockwise, like we just saw, right? But if the force is being applied in this direction, the object will move in a clockwise direction. So whenever we want to understand the motion of the body in a clockwise or in an anti-clockwise direction, we always have to understand that in which direction the force is getting applied or at which point the force is getting applied. That is a very important requirement in order to understand the direction of the rotation of the body. So like we just saw that the torque is equal to force into the perpendicular distance from the line of action of the force and the point of pivot. Now we can see that the torque will increase if the force is increased, and the torque will also increase if the distance of the action of the force increases from the point where the object is attached. Now there are certain examples of torque in our day-to-day life. The most common is the opening and closing of the doors in our house. We see that if, for example, this is a door, the handle is placed at the farthest position. For example, the door is attached at this position, so the handle is placed at the farthest position. It is not placed here or in the middle or anywhere near the hinges. It is placed as far as possible. So like I told you that the distance of the point of application of the force has to be the highest from the point of attachment. So from the hinges, the farthest point is this, right? So the door handle is always attached at the farthest end so that the opening and closing of the door is easy. You can try at your home to open the door by pushing the hinge portion. You will find it is almost nearly impossible to do that because you have to apply a very huge amount of force to do that, which is not possible. Another example is in case of driving a car. We see that in case of a steering wheel, there is a circular portion in the middle, but we apply a force on the rim, on the end. Why? Why don't we apply it at the center? Same reason, because at the center it is pivoted. So our point of application of the force has to be at the farthest position. That means at the rim. Similarly, in case of a hand grinder was used by the people in the olden times in order to crush grains and all. So over there also you will find that if this was the stone of the hand grinder, the handle was placed here. The point of pivot was at the middle, but the handle was placed at the farthest point, so that even by applying a very small amount of force, you will be able to crush a lot of grains without applying too much force. A small force will be enough. So whenever we want to turn something, we want to make something rotate in a circular path, we always have to apply the force at the farthest point from the point of pivot. Okay, similarly in case of a hand spanner, or you can say when we use the device in order to tighten a screw, it looks somewhat like this. I guess you all know about it, isn't it? So if the nut is here, we apply the force over here. We do not apply the force here, because this is the point of pivot, right? And if we apply the force at the farthest distance, even by applying a small force, we can produce a large turning effect. Same thing happens with bicycle. Whenever we are pedaling, actually we are not just rotating the first gear, but also the gear of the backward portion. So by applying a small force in the pedal, which is in the front, you can easily rotate the gear which is present at the backward portion, because there is a huge distance of the pedal from the small gear which is present in the back side. Okay, so whenever you want to produce a larger turning effect, you always have to apply force which is at the farthest distance from the point where actually the object is pivoted, the object is attached to the axis of rotation. Hope you have understood. In the next video, we are going to learn about couple and many other things. We are also going to do certain numericals. So thank you for listening patiently. Meet you soon.